welcome to today's webinar, Maximizing Your Investment with Smart HVAC Decisions. My name is Tony Lang, and I'm the Associate Editor of Cannabis Business Times. In today's webinar, we're here to talk about some of the most important considerations in making an informed decision when investing in a commercial grow HVAC system. During this webinar, we'll discuss capital and install costs, energy use controllability, yield, and maintenance and downtime costs. First, a few housekeeping items. There's a Q&A box at the bottom of your screen. If you wish to submit any questions you may have throughout the presentation, make sure to drop your questions there, and we'll try to answer as many of them as we can at the conclusion of the presentation. Also, we'll be emailing a recording of this webinar to all registrants. The video link will be available in 5 to 7 days for your review. And now I'm pleased to welcome Geoff Brown, Vice President of Product and Business Development at AGronomic IQ.
Thanks, Tony. Appreciate that intro, and glad to see you guys here taking the time out of your day on this Wednesday afternoon. So very much appreciate you guys joining me. Like Tony said, I've got a webinar for you here that's going to focus on sort of the boogeyman that is HVAC and how to get the best return on your HVAC dollar investment. Over the course of this webinar, I'm going to talk about the capital and installed cost considerations, the time to market considerations, some yield and sort of general business development considerations, as well as going through a couple of slides of some weird stuff that we see in the field that are good watchouts for you as a facility owner, manager, designer, or builder. So without further ado, we'll get into it here. So just a little bit of background. Like Tony said, I'm Vice President of Product and Business Development with AGronomic IQ. AGronomic IQ is a brand of dehumidified air solutions, which is owned in turn by Madison Industries, which is a Chicago-based privately held manufacturing holdings company. I first started in the industrial dehumidification space in 2003, and I've spent now about 10 years on the application side. So starting in early 2012 in the design and sales side of large natatorium dehumidifiers is ultimately where I came from with Stresco Technologies prior to its acquisition by Dehumidified Air Solutions. And when that came about, we saw an opportunity to transition into the emerging, at the time, Canadian grow market, and I was part of the product development team that created what is now the Agronomic IQ brand of product. Also authored a book on the subject that's going to have its newest edition coming out here very shortly. Again, trying to demystify some of the HVAC parts in particular of grows. Anyways, we'll talk about that in a few minutes here. In terms of Madison Industries, again, fairly large parent company, very large footprint across North America as well as the world. Currently something like 216 factories across 45 different countries. We're part of the Madison IAQ division, which is the indoor air quality division. Again, focused on bringing quality HVAC products to various different marketplaces. And some of the other companies within MIAQ that you may have heard of would be Thermistor and Quest, for instance, or Big Ass Fans. So some really powerful brands that allow us to transition some internal knowledge, some supply chain, manufacturing capabilities, all sorts of things. But I guess the point here is we're a very large company. We're not going anywhere. So we're really focused on this market. Madison sees this as a growth opportunity for us and for North America generally. And so there's a huge focus on our marketplace, and we're well positioned to take advantage of where this market is going. And fortunately, we've got the the desire to be better at what we do and to continue to drive thought leadership and some really cool, innovative technology in terms of what we're supplying to the market. So over the course of this, again, return on investment, obviously, you can't get a return on anything if you're not actually going to invest. Investment is the key part of that. And so how do you spend good money, good smart money? You're going to be spending money anyway. It's part of building a grow facility. You don't have a choice. So how can you maximize what you're doing there? But it is a multifaceted conversation. So there's a lot of different factors that go into this in terms of where you're spending money and where your long-term profitability is going to come from. Or I would say that most people understand the capital piece of equipment costs. It's the price tag that you see from day one. Installed costs can be a fair bit more nebulous, but then there's also the energy use costs, controllability. And in controllability here, I'm largely talking not just about how accurately or tightly a system controls your space, but also how much time you as a business owner have to focus on HVAC instead of the other parts of your business. Ultimately, you're in the business of growing quality product and packaging and shipping quality product. And if you're able to think about stuff that's not HVAC, you're able to do that more effectively. And again, that's a piece of this conversation, of this investment conversation is, can a quality HVAC system free you up to focus on what you need to do? The yield from your facility, obviously very important. If you're able to increase your yield, everybody wants to, but if you're able to increase your yield, it changes the economics of a facility in a really, really big way. And then there's sort of some of the ongoing costs of running the facility. And so things like maintenance, and then the potential effects of downtime. And we can talk about some of those costs. And then some of the resources, again, that we make available to the marketplace. Getting grow rooms right is one of those resources. We've got a couple of others that are available through our rep network as well. But let's hop into some of these cost items here. Just in general terms, capital costs are the cost of the thing that you're buying. So when we're looking at this, there's a bunch of different categories of equipment that you can buy. In general terms, the Agronomic IQ product line it's a unitary piece of equipment. It's designed as a single piece of equipment that handles the entirety of your grow room's HVAC demands, heating, cooling, and dehumidification. And we're cost competitive with unitary equipment, but we're going to be more capitally intensive than packaged cooling equipment, a typical York, Carrier, Lennox, rooftop, plus standalone dehumidification. We're going to be significantly less expensive than a true custom air handling solution. And then there's the chilled water boogeyman that sort of exists in the corner, and that's a big it depends. The chilled water piece is probably the most challenging piece of this marketplace, particularly as the market continues to legitimize. I've said it before, if you've seen some of my other webinars or seen me speak elsewhere, as the engineering community gets involved in these projects, there is still no guidance from groups like ASHRAE on it. And so in very large projects, the engineering community has tended in the past, certainly, to focus on what they've done for very large, 1,500 ton, 2,500 ton buildings. And that's historically been central plant. That's how you handle, generally speaking, a large office tower or a university campus or big sports center or whatever. And they can be applied successfully to this marketplace, but they're very expensive to do properly. And it's that doing properly piece that's challenging. And again, I've talked specifically about the difference in technology in some other places, and I'm happy to answer some questions on it. But the long and short of it is, if you're going to properly design a chilled water system, it's both more expensive to install, it's more expensive to buy the capital equipment, and it's way more expensive to run, although you end up with very tight room control. So there's a bit of a there's always a balancing act there. In terms of the installation costs, again, capital costs aren't the only piece. We would ask that we're always looking at the total cost of an installed solution. So that's the plumber, the electrician, your mechanical contractor doing ductwork, everybody related to getting the equipment up and running successfully in that building. And so integration, for instance, between a building automation system and the room itself, and ensuring that the equipment is operating the way you're expecting it to for that room. And that's sort of that startup period. The longer that startup period takes, the longer it takes for you to achieve the full yields available from that facility. And the longer it takes you to see a true return on your investment. So in general terms, unitary systems are quicker to install and they're quicker to commission. It's a single piece of equipment, you put it on the roof, you hook up ductwork, power, plumbing to it, and it's got integrated controls that make it very quick from that point on to move forward with. The don't ignore redundancy in particular is looking at things like chilled water. So if you're doing a big central plant system, by definition, it's a centralized system that feeds your whole facility. If your central system that feeding your whole facility goes down, you have a major, major problem on your hands. So how do you build in that redundancy in something like a central plant or any other facility or any other equipment type for that matter? So always something to be aware of. And again, this isn't the answers to these questions are always going to be very, very specific to you and your facility and what your desired outcome from that facility is. So I could sit here and tell you what to do, but I'm not going to be right for 99% of you. Every time this is a nuanced conversation with a lot of different factors. So what I'm trying to do here is provide some background into things that you should be looking at, things you should be considering. And again, I'll show you some pictures of what happens to some of these facilities later in their lifetime and how to avoid some of the problems that we see. So controls and maintenance, the controls piece certainly could be lumped in with the installed cost, although I want to call it out specifically because if you've got a facility, you need to have the capacity to have it do what you want it to. You need to be able to tie in, your lighting control with your HVAC control. You need to be able to sense the room conditions properly. There's a bunch of different ways of doing that, but you need to ensure that your equipment is controlling to the temperature that you want it to, and basically accurately controlling the space. And so again, with unitary equipment, you've got a built-in control system, you've got built-in sensing, and then you can take third-party sensors or canopy sensors or something like that to augment that system. With basically all of the other types, whether it's a packaged cooling plus standalone or a custom system of some kind, whether that's chilled water or other custom unitary equipment, the controls piece is going to be up to a local controls integrator to manage. And that piece can both take a long time and cost a lot of money. And there are lots of people who are jumping into this marketplace with both feet. They're seeing it as a bit of a gold mine, and I understand why. That said, if you're relying on a large building automation provider to give you a solution, you're actually relying on a local company to integrate that solution for you, who may or may not have ever worked in a grow facility before. So there's always some caution there in terms of how standard can you get with controls? Is there something off the shelf or a known integrator that you can work with? You don't want to be somebody's R&D project. In terms of, again, the controls and maintenance piece, the number of overall units in your facility, the number of individual units, the more units you have, the more redundancy you have, but the more points of failure you have, and the more things that you need to either fix or clean or replace. So, I'm talking about filters, for instance. If you've got 30 small dehumidifiers serving a space and you have to change those filters between every cycle, there's a cost associated with that. There's a cost associated with putting a maintenance guy on a ladder and having him actually change those filters. And then if you have a contamination event, or if you're in a jurisdiction requiring it, needing to clean those units on or between every cycle, it, again, represents a pretty significant cost, or the opportunity to have a pretty significant cost. So all of these things factor into your overall cost of ownership. And obviously the service and warranty offering that accompanies units is very important. So in general terms, unitary equipment has a warranty. It has a single person that is responsible for it. You want to ensure that the person you're buying from is the OEM. So you don't want to end up in a situation where the brand of equipment you bought isn't manufactured by that person, and there's the sort of necessary finger pointing that exists between the person you bought it from and the actual manufacturer of that equipment, who's responsible for offering service or warranty repairs or whatever. These are questions that you want to ask early in the system, early in the unit design or the system design. Another factor, of course, is energy use. These facilities are energy pigs. It's something that everybody's aware of, but it matters. So one of the biggest factors, at least in terms of energy use for unitary equipment, is because properly designed unitary equipment is able to use 100% of the compressor waste heat, you've got the capacity to reheat for free, effectively. Anytime you've got a compressor operating either in cooling or dehumidification, you've got enough energy in that system to make up all of your reheat. It means that you're not burning BTUs on both sides. And again, as this market matures and as the impact of this market matures, it's really important to ensure that we stay compliant with some of the existing rules that are currently not being enforced. So one example there's been a DOE rule on the books for a long time that says you can't pay for both heating and cooling BTUs in the same space at the same time. Again, this rule is largely ignored, but the last count I saw, which was a 2019 number, showed that indoor cannabis facilities in North America accounted for something like 3.5% of North America's energy use. I suspect that number is quite a bit larger today. And so as that number gets bigger and bigger, we're going to see a repeat of the data center stuff of the 90s, where there's much more focus on drawing that into an energy efficient or as energy efficient as possible. And as a result, enforcing some of these existing rules. So again, in the short term, you're able to achieve significant energy savings by just not paying for both sides. You're not paying to cool waste heat from a dehumidifier, or you're not paying to reheat a chilled water system that's using fairly cold chilled water to achieve the dehumidification you need. But you still need to be able to keep the air warm enough that you're not killing your plants. In the short term, again, there's an energy savings. In the long term, there's code compliance that's going to become more of a factor here. And one of the tools that we've built is an energy calculator that allows us to compare some common solutions with the Agronomic IQ solution and what that looks like. In general, the unitary systems with integrated reheat, again, have something like a 30 to 50% savings in annual energy use. And that represents 15 to 25% of the capital cost of that equipment on a per year basis. So when you're looking at the overall, again, return on investment of your facility, that capital cost or that energy use reduction is important. Obviously, makes a bigger difference in a place like Puerto Rico, where you're paying 25 to 30 cents a kilowatt hour versus Oklahoma at 7 or 8. But regardless. The other piece is, as a result of this calculator and some other things, we've managed to support more than $1 million in utility rebates over the last year. And so a utility rebate is basically just an incentive to buy something that the utility considers to be more efficient. Utilities are incenting facilities to do this because there's a real cost associated with the utility increasing available electrical infrastructure. And so if they can avoid doing that or offset some of that cost, they're generally willing to give some of it back. And so that's one piece that we actively help our customers with, and again, through Rep Network and other partners actively work on. And basically we produce an output that looks something like this. And so this is one we've done for a flower facility using Colorado as a, this one's using Buckley Air Force Base in terms of weather data. And we have a fair bit of calculation that goes on in the background, but you'll see that in general terms, we're, again, between that 25 and 50% energy savings. This one happens to be about a 35% energy savings on an annualized basis. The thing that makes a big difference here, though, and the piece that I really want to draw your attention to is on the left side, you'll see there's an energy savings number, 26 grand a year. 26 grand a year is a very solid number in energy savings. And again, it represents, in this case, about a 15% savings on the capital equipment per year. Great. But the yield boost piece matters way more. So 26 grand in energy savings, awesome. 500 grand in yield boost. Well, what does that mean and how do we achieve it? And so I'll get there in just one second. Just another quick reminder again, if there are any questions that you guys want me to answer, please throw them in the question and answer bucket within the Zoom window, and we'll get to them at the end. And we'll talk about, answer what I can, and again, email out a copy of those questions and answers, follow up here. So in terms of the yield boost, we've got a couple of numbers here. Budgeted yield per square foot number, a business plan number is very typically something like 55 grams a square foot. That happens to be roughly the average. And our bulk price per pound varies wildly, but $1,550 per pound was the 2020 average. Again, really depends on what you're growing and for what purpose. If you're growing a very consistent craft flower, you're going to achieve well better than $1,550 a pound. And if you're growing outdoor, not really part of this conversation, but if you're growing outdoor just for biomass to feed into extraction, you're probably not achieving that much. These are where these numbers come from. Again, this is CBT had done this survey, and that 55 grams a square foot is really sort of the average. So when we're talking about yield, what does this mean? Well, a bunch of different things. Your facility has an opportunity cost in delay. So the longer it takes your facility to get up and running with whatever HVAC solution or your construction timeline, as well as how long it takes you to get your facility running optimally. So if you're able to build your facility very quickly, but it takes you a year to get it running well, there's a cost associated with that. And the number is something like $2 a square foot of canopy per day. So it's a huge cost that I think is largely ignored in this market, unfortunately. From our perspective, we're able to help achieve better yields by controlling the room more accurately. The more accurately we can control the room, the more time and energy your grower can focus on the other pillars of good yield, that is fertigation and lighting. Again, the things that growers really focus on. I find that in general terms, when we're talking to facilities that are maybe not doing as well as they'd like to be, they find their HVAC to be a distraction. It's something that it's a black box on the roof. It may do stuff, but we don't really understand how or why it does what it does, and it's never right. And so, like I say, it's a distraction. It's a distraction for your grower. It's a distraction for your management team, who really ought to be focused on, hey, can I make my business more efficient? And hey, how do I expand? How do I get more capital to build another building? And so from our perspective, we want to partner with you to ensure that your HVAC is easy. And when we're talking about ROI, something as small as a half gram improvement per square foot, 1%, which is absolutely nothing, can represent like 60% of the capital cost of HVAC on that room. It's the single biggest piece of the ROI, the ROI analysis, really. And we have many facilities that are well north of 100 grams a square foot in terms of production. So that's again a huge difference. If you're budgeting 55 and you end up at 70 or 80, that obviously does huge things for your business and your business plan overall. Obviously harder to guarantee, right? I'm not in control of your fertigation, of your lighting, of your grow schedule, of contamination, of a whole bunch of other things. But my goal, or our goal, when we're applying HVAC to a facility is I want to remove the distraction of HVAC. I want you to be able to trust that your HVAC is going to work. It is mechanical equipment. It does require some love and care and attention, like all mechanical equipment does. But in general terms, I want you to be focused on growing. And that's really what it's about. And when we're talking about controlling a room more accurately, we're talking about a room that looks like this. So the room on the right is an Ag IQ controlled room. The room on the left is typical HVAC with standalone dehumidification. And so what you can see is, one, much more accurate temperature control. We're not either above or below target. We're really bang on over the course of that cycle, and much more accurate humidity control as well. And every time the humidity either goes well above target or well below target, you've stressed out your plant. You're forcing it to either, when your humidity is too high, you may be dealing with some microbial contamination or at risk of it, but you're also slowing down transpiration from the plant leaf and slowing down its growth ultimately. Similarly, if your room's too dry, your plant is stressed out, it's going into a drought mode, and it's not going to be growing as much. So this is one of those things that the more accurate you can control it, the more accurately we're able to basically put the control in the hands of your grower. You can also, if you have aspirations or if you are a multi-state operator, if you don't have tight room control, how do you determine which of your growers have a good recipe, which of your growers are doing well, versus which of them are, saying, hey, HVAC's the problem, not me. So from a management perspective, it's really is again, we're trying to make it easier, trying to allow you to focus on the business of growing and not on the HVAC side. Here's another example of, again, a similar room with much more tightly controlled conditions. And again, you can see, in this case, there's a 20% relative humidity swing in that room on the left. And, we're sub 10% in the room controlled by Ag IQ. So, we're controlling it in gross numbers about 50% tighter, although you can obviously see that it's a much more stable environment as well. This also has an energy impact to your facility. So when you're banging stuff on and off, which is ultimately what's happening here. You've got a standalone dehumidifier or a packaged air conditioner that, okay, my room's too hot, I'm going to turn on 100%, I'm going to drag the room down until I'm at my low deadband set point, I'm going to turn off, I'm going to wait for the room to heat back up and rinse repeat. There's no modulation and control there. And so not only is your room environment not that stable, but it's also an energy pig as a result. And so the rooms that we're seeing here are treated by our flagship equipment, and that is the compressor wall units. If you guys are familiar at all with fan arrays or that kind of concept, we've basically taken that and applied it to compressor circuits instead. So instead of having a couple of large compressor circuits, we've got many small compressor circuits, and each one of those compressor circuits is still served by a two-stage compressor. So you end up with a lot of stages of control available in these, which allows them to tailor themselves very nicely to the room demands. So outdoor equipment from 10 to 121 tons. So small rooms are large. we always recommend, or would always recommend, having multiple pieces of equipment per room, just for redundancy's sake. You know, a minimum of 2 units per room is generally a good practice. Again, because each of those compressors is a 2-stage compressor. In low speed, they're primarily sensible. That is the air conditioning piece. And in high speed, we add the latent back end, the dehumidification piece. So we're able to turn those compressor circuits on or off, and at different stages, again, to very tightly tailor the room, or the work that we're applying to the room demands. The stage of your plants, whether they're, you know, if you're a veg in place, whether those plants are small, and as you know, following them through the flower cycle, through sort of week 6 of flower, where your dehumidification demand is absolute peak, and then back again as that flower cycle ends, you start cooling things off, drying things down. We can tailor our capacity to it very, very tightly. And you know, there's a couple of quote unquote weird things about these units that are done for a very good reason. One, they're all water cooled or glycol cooled. We have a packaged configuration available for all of the units, or they can be done as site splits or split fluid cooled units. But we're using a glycol cooler because it allows us to completely isolate the refrigeration circuits, those small pods that I talked about, from what's happening outside. And so it means that, in particular with low ambient conditions, so when it's cold outside, we're able to still do full cooling and dehumidification without having the compressor circuit need to work in a -20 or -30 or -40 degree environment. And we have these units successfully deployed in places like Edmonton that are unnecessarily cold, and people, frankly, you know, I struggle to understand why people live there. Different story for another day. Obviously, you know, we do these in pad mount or roof mount configurations. So, you know, in this case, we see a pad mount version with top supply and top return. They're available as downflow, bottom supply, bottom return, as well as horizontal or left or right configurations. So really work with your building designer, your engineer on a site to figure out what works best for them. Again, designed for the cannabis market, designed for operating in a high enthalpy environment in the cold or the heat. And so when I say a high enthalpy environment, one of the, again, the challenges with standard rooftop equipment is you've got a box on the roof, and if you turn that box off and it's not designed for it, well, that box is going to get wet because the box is going to be cold, there's no air flowing through it, and you're going to have condensation problems in it. And again, this is one of the challenges with on-off control of typical HVAC, is you end up with a bunch of other problems that sort of come out of it. So again, this is typically how we would apply equipment to a facility. We are going to be releasing a new style of indoor unit quite soon, so I can provide a bit of a teaser there. Basically what we're doing is we're taking the compressor wall technology, multiple small 2-stage compressor circuits, and dragging those into our indoor footprint, which is a little more compact. Generally speaking, we see indoor equipment applied to greenfield buildings. Retrofit buildings tend to have outdoor equipment. And so it's going to depend on, you know, your specific needs. There is no right answer. Both apply work to a room very effectively. It really just is what is best for you and your designer. So I just want to talk or maybe generate some questions or generate some concepts about your, I'm going to go through a couple of pictures around some facilities we've seen, stuff that we've seen done, and I want to understand from you whether you see similar stuff in either facilities you're involved with or have similar challenges that exist, and happy to answer any questions you have on the subject. But here's an example of a grower that ultimately just didn't choose the right partner to build their building. And so what we've got here is the top of a grow room. This is a flower room, and this grower has elected to use disposable ductwork with the intent of throwing it out between every flower cycle. They've got, typical double end discharge at the top of their room. They've got high supply and high return these return grills here are in the ceiling, and they've got their supply up high. Obviously not, that ductwork isn't going to be getting air anywhere useful. They've got no air devices in the room to mix the room in any way. So in general terms, I'm not a fan of air rotation fans in a space. They basically are energy pigs. They're not particularly efficient at moving air around, and they tend to be applied more universally than they ought to be. You can achieve good air movement in the space just with good ductwork design, and not have that energy penalty of that extra set of fans. Again, any plug load in that space, any energy you spend in that space, you also have to spend in energy cooling that energy, right? So if you have a horsepower of fan in your room, you've now got an extra, call it 3,000 BTUs that you have to cool every hour. So there's an energy cost to running the fans, and then there's a second energy cost in cooling the fan energy. But in this case, there are no air rotation fans. There's nothing getting the air to a good part of the room. And this was allegedly demanded by the master grower, this configuration. They've used this before, they know it works. Ultimately, unfortunately, not a productive space. And so the simple fix to this is get ductwork with air devices that point in the right direction. If you get air to the plants, you've solved the problem. And so ductwork is not a particularly expensive thing to do. It is a cost that I think sometimes sneaks up on people. But we're talking about, maybe 10% of the capital cost of equipment on a particular room in ductwork. And so if you're able to save energy in air rotation fans and achieve better results from that room, that little bit of money in a one-time ductwork cost is really smart. In this case as well, of course, different facility, but this is a facility that's got a high return system. Their return up high is reading basically the temperature right off the lights. They are not measuring temperature at the canopy level. And so this room in particular, when I took this measurement, that measurement says 64 degrees Fahrenheit. The room was downright chilly, but the equipment was seeing an 85-degree return air temperature. So about a 20-degree spread between what the canopy is seeing and what the equipment is seeing. And that's indicative of poor air distribution, poor mixing in the space. And again, that air distribution can be accomplished with good ductwork design, with air rotation fans intelligently placed. Again, that's one of those things that we see all the time is growers are very good at creating horizontal air curtains in their room. They've got a bunch of air rotation fans pointing sideways, high supply, high return, and then wonder why no air gets down low. Well, I mean, you've all walked into a Costco or a Target and had the fans blow on you. Well, it's literally creating an air curtain. It's designed to block mixing between inside and outside. And if you do that with your air rotation fans, you're going to accomplish exactly the same thing. So intelligently applied air distribution is really, really important. In this case, again, another facility that was built by, in this case, a new builder to the market. This was their first facility and didn't understand that the application of a wall-mounted thermostat nowhere near the lights and nowhere near air distribution wasn't going to accurately measure their space temperature. Seems obvious. Everybody who's been in one of these rooms before understands the impact of the lights, but there you go. And so again, I think my message there is you want a company, a construction partner, an HVAC partner, an engineering partner that's invested in your success, right? This is a market where it's easy to have things go wrong, and you want somebody who's going to be there and stand with you through thick and thin and ensure that things go well for you ultimately. Same facility as that last picture. That is a return air grill in the hallway. So this is not part of the grow room, but obviously there's light leakage between the grow room and the hallway. Well, light leaks in both directions, obviously enough, which means that if that hallway light is on during the lights off cycle of flower, you've got a light problem. Again, I think my message here is there's lots of little things like this that people who work in this industry a lot, who visit a lot of facilities, see. There isn't a person out there who would ever consider opening the door between a lights on hallway and a lights off flower room. So why would you accept air leakage like this or light leakage like this? Now, of course, if you've got light leakage like this, you probably also have air leakage, which means that you've got a direct path between your hallway and your grow rooms, which means that you've got the capacity for contamination, again, through all of those facilities. So get somebody who understands what they're doing and be involved in the process, right? You want to ensure that you've got visibility into these things, that you're not just blindly trusting. This is a trust but verify. Watch what's happening, ask questions, ensure that when you're signing off on a room or a facility that you're truly happy with it, and that you understand any deviations from your spec. You understand why a contractor changed the basis of design. Ensure that they're not doing that to add some extra money to their pocket, but they've got your best interest in mind. Again, you're looking for a partner, not somebody to blindly make money at your expense. So that's about it for my main presentation. I'll take some questions now if you guys have any. And do you see some that have popped up? Tony, were you going to read them out, or is that the
Yeah,
plan?
yeah, I can do that for you, Geoff. So,
Yeah, sure.
and just a reminder, if the Q&A box is open still throughout the Q&A here. So if you have follow-ups or want to ask a question, drop your question down there at the bottom of your screen. Well, let me just start off with a question from Nicholas here. He's asking, how many times per hour should I renew the air in my indoor grow room?
What a great question. So I'm going to say there probably isn't a right answer to this. If you're not going to be able to, if you're not supplementing CO2, then the answer is quite often. You're probably looking for, 3 to 6 fresh air changes an hour. If you're supplementing CO2, the current sort of, at least best industry practice would be you're probably having a sealed room altogether. CO2 is surprisingly expensive. It's probably going to be your single biggest cost after power. And so most people would then say, if you're supplementing CO2, to not introduce any outside air or any fresh air changes over the course of your lights on cycle. And then there's some, again, some facilities are experimenting with different things, but I suspect that it's probably worth your while to do a fresh air change or two during the lights off cycle, introduce some outside air, some fresh air. Again, you have to be careful about introducing contaminants. You certainly don't want to introduce any, if you're in an area, Southern Ontario, for instance, there's lots of either greenhouse or outdoor grows. You certainly wouldn't want to be introducing a lot of outside air with other grow facilities in your area for fear of either contamination or pollination. So again, it's going to be a very site-specific conversation. But again, I would say in general, 3 to 6 air changes, fresh air changes per hour if you're not supplementing CO2. And if you are, again, general best practice there is probably no fresh air changes during the lights on with an air exchange or two at the beginning of the lights off cycle.
Right, okay. And then this question is from Wayne. Said this might be outside the scope of this webinar, but how does Agronomic IQ control the sensible heat ratio? And also, how is that set point set by a user, or is it based on other set points?
Yeah, so I mean, this is getting into the weeds of control algorithms, but basically the user sets a target temperature and relative humidity for the space. So, you know, just for grins, middle of a flower cycle, 76 degrees Fahrenheit and 55% relative humidity would be, again, not atypical. And so in setting that in the equipment will then look at the airstream either coming back to the equipment. So I see another question there around air changes per hour independent of outside air. We're generally seeing with our equipment between 40 and 60 air changes per hour, which means that air coming back to the unit, if you've got good air distribution in your room and good mixing, is going to be very representative of your canopy temperatures. But the air coming back, or the air that we're controlling to, whether that's a canopy sensor or the return air, will then define an operating mode for the unit. Are we in cooling, heating, dehumidification, or some combination thereof, right? You can cool and dehumidify at the same time, or you can heat and dehumidify at the same time. And then on the basis of that, if we're targeting cooling, there's a couple of different things we can do. We can run compressors in low speed, which is a sensible primary mode to reduce the amount of dehumidification that each of those pods do. We can increase the airflow rate through the unit to increase the sensible heat ratio. We can increase or close the bypass damper on indoor equipment to increase the, again, airflow rate through the evaporator coil, again, to reduce the sensible heat rate, or sorry, increase the sensible heat ratio, reduce the amount of dehumidification we do. And vice versa, all of those things work, right? We can, if we're in a dehumidification primary mode, we would kick on a compressor at full speed, get full latent cooling out of it, do as much dehumidification as we can, and then have as little quote unquote waste cooling as possible. We can also slow down the air through coils to accomplish a similar thing, or again, to change that sensible heat ratio. That's all done internally to the unit. And so that's not an algorithm that is controlled by the user or that needs to be programmed by a local controls integrator. That's, I think, probably the biggest benefit of unitary equipment is that stuff is all baked in. We've got thousands of units out in the field with control algorithm, you know, with our control algorithm that does this stuff for you, basically.
Okay. Then got a question from Tony here. At what point would it be reasonable to integrate Agronomic IQ with the design team for an indoor grow?
Generally speaking, as early in the process as possible. You know, once you have the basics set, you know, it's hard for us to size equipment if you don't know what kind of lighting you're using or how big your rooms are. But ultimately, the earlier in the process we're integrated, the easier it is to fit our equipment or any equipment into that facility. So one of the things that we could do, for instance, is say, hey, if you want to design around 55-ton pieces of equipment and you want 2 of those per room, well, here's the maximum room size that you can get. So if you were considering having slightly smaller rooms or slightly larger rooms, well, you may have some wasted equipment or some wasted floor space as a result. So working with your design team early can help us optimize a facility with, you know, unit configuration or tonnages versus individual room sizes, even versus lighting type. So I would say that there's never too early an opportunity. We're probably the next call after deciding on an architect and an engineer.
Gotcha. This one's from Joseph. Are you dehumidifying to the point where you're producing enough condensation flow to warrant the need for heat trace during winters?
Yes, absolutely. So in general, if you've got rooftop equipment, we would prefer to have just a bottom drain connection that goes through the roof curb and so stays in a conditioned space. If you're going to be throwing or having a side condensate drain either onto a roof or, that picture I showed of equipment on a pad in a parking lot, it will need to be heat traced. A 120-ton unit will produce something like 400 pounds an hour of water, maybe a little north of that, depending on your conditions. And so you could very quickly end up with a very large skating rink in the winter, and it's a significant concern. So yeah, absolutely. Condensate management and preventing that from freezing is very important. And again, a very typical consideration of any dehumidification equipment outside. Right. That said, if you were to be building a greenfield building, part of the reason that Canada sees a lot of indoor equipment is because it's cold out, and maintaining equipment on a roof in the winter sucks. And all of these other issues that sort of accompany that, like heat tracing condensate lines, can be a problem. If your equipment's indoors, obviously you don't have any of that concern.
Right. And then this question's from Michael. It's talking a little bit about the HVAC relationship with lighting. Have you observed significant differences in HVAC/deload between HID lighting and LED lighting operations? And can you quantify that difference for us?
So the short answer is yes, there's significant differences between them in a couple of different ways. So there's, people are applying LED lighting either in an effort to reduce their lighting wattage or to increase their micromole density. And so basically, if you were a discharge facility at 50 watts a square foot, you can probably achieve pretty close to the same PPFD with 35 watts a square foot of LED, or you can increase your lighting intensity by using 50 watts a square foot of LED. In both cases, it affects your HVAC system differently. So if you're going to just use LED as a way to reduce your lighting energy, what you generally do is you reduce your leaf temperature. And so what that means is that you run your room hotter to maintain a similar leaf temperature to what you would do under discharge lights. Again, you're not getting that same amount of infrared radiation off the lights. And so your leaf temperatures generally end up colder with equivalent air temperatures. And so you need to reset your whole facility hotter, and thus to stay, and as a result of that, to stay in the same band of the VPD, you need to run more humid as well. And so it very much changes the sensible heat ratio target of equipment. So generally speaking, it's something that's not a drop-in replacement, or at least is going to require a lot of consultation with an HVAC manufacturer. It's not, that's not an nth hour change to go from discharge to LED and just hope that everything will be okay. It's a pretty significant change in terms of your overall HVAC need. Now, there's still, ultimately it is a system. A watt in is a watt out, or a watt in is a watt that an HVAC system needs to deal with. So we're just changing the ratio between dehumidification watts and sensible cooling or air conditioning watts in that. That's ultimately the sort of end goal there. But yeah, the difference is pretty significant. And again, is mostly in terms of the difference in temperature that you're running the room, and thus, air on temperature for coils, sensible heat ratio for the equipment itself.
Right, gotcha. Curtis from Saskatchewan has a question here about his, said he's designing a micro cultivation, 2,152 square foot operation in Canada. He's talking about having a 1,700 square foot bloom room, 180 square foot mother room, and a 220 square foot veg/clone room. Do you have any recommendations for those varying room sizes and the different cycles of growth stages there for him? Yeah,
so, in general terms, this would come into our client intake And what we would be looking for from Curtis or any other grower is, let's talk about your rooms. What kind of lighting do you have? What kind of desired temperatures do you have? And what's your end goal? Generally speaking, in Canada, micro are doing high quality dried flower as an output product, which means that in general, you'd be looking for pretty tight control of your space, but you may have very specific demands in terms of temperature and relative humidity, particularly towards the end of a cycle. Again, especially if you're intending to get a particular color or terpene content or something like that. So our client intake form would look at how big are your rooms, what kind of lighting are in your rooms, what kind of watering rate are you doing? We really want to know everything about your facility in order to better understand what you're doing and how our equipment may or may not be suitable for it. And again, your different room sizes. And so basically all new growers all new customers of ours go through the same intake process there. Filling out that form that is enough for us to start a conversation with you, to start understanding your grow and what you're doing, what you're wanting to accomplish, and how we can best help with that.
Yeah, and there's a few general questions revolving around, the next steps people can take if they want to make the investment to, unitary equipment here. And Curtis and some other people who have some follow-up questions about install time and all that, definitely in the chat box. Geoff's email is available there, and we can also follow up with you after the meeting. Maybe one or two more quick questions here for you, Geoff, if you have time. Can you talk a little bit about, and this question's from Al, can you talk a little bit about the efficiency of your system versus that of desiccant systems or typical systems that maybe aren't necessarily designed for the specific purposes that Agronomic IQ designed its systems for?
Yeah, sure. So again, I'm going to speak very generally here because it's hard to be 100% accurate 100% of the time, not knowing what type of desiccant we're talking about. There are some interesting technologies with liquid desiccants that can offer both cooling and dehumidification in a quite efficient way. The challenge generally with liquid desiccants is they tend to be quite to extremely corrosive, and so provide some challenges generally to equipment, to ductwork, to piping, to your facility generally, as well as sometimes being quite toxic. Traditional desiccant system, the stuff that most people think of when they're talking about desiccant is using effectively silica gel, the same stuff that you get in electronics, and is a very energy dense process. So by running a desiccant wheel, you run a process airstream through that, the desiccant media absorbs the moisture, and then you need to have a regeneration system that's typically either electrically or gas fired, but that heats that desiccant media and basically burns off the water into that regeneration airstream. The net effect of that is a quite high energy use, and a heat source for your space. So that because that wheel is getting regenerated and getting hot, the process air that goes through that wheel tends to also heat up. And so you may have a net heating effect from that may or may not be desirable. So where do you apply desiccants appropriately or most appropriately in this marketplace? I would argue that the most appropriate place would be drying rooms, would be a good example. Desiccant systems are capable of very accurate dehumidification control, and applying a very consistent dehumidification amount or quantity, pounds per hour or delta grains to an airstream across a very wide range of temperatures. So if you wanted to dry, for instance, at 60 degrees Fahrenheit and a 40% relative humidity, you have a very low dew point. You've got a dew point that's lower than DX or any direct expansion dehumidifier can achieve. Your only option at that point is to go desiccant. And so it would be generally not the most efficient application, certainly not the most efficient application for a flower room or a veg room, but maybe the most appropriate for a drying room or an extraction space or processing space of some other form.
Last thing here, and again, if we didn't get a chance to go over your questions, we will follow up with you, and you can also follow up with Geoff directly following the webinar here by email. Just a basic question from Herschel here. He's asking if you have a white paper or primer on HVAC for the cannabis industry. I'm sure the short answer is yes, but are there any avenues or places that people can go to get more educated on some of the nuances with HVAC and what exactly their investment would include if they choose to partner with Agronomic IQ?
Yeah, so I think the best place there is just to drive to our website, agronomiciq.com. We do have a number of white papers, some case studies, things like that on the website. You can also get in touch with us directly, either myself directly or our sales team. Obviously the sales team is a little more involved in the day-to-day sales operation of our business than I am at this point. I've transitioned out of that and really focusing on new product development and understanding the needs of the industry and how to integrate that into our product line. So that's been a fun transition for me, in all honesty. But ultimately, Herschel and anyone else, the best place for resources is our website. And if you're not finding what you're looking for on the website, then get in touch with us and we'll happily help you out there.
Right. Well, again, sorry if I know we didn't get to some of your questions here, and we're gonna have to cut it off there, but a video link of this webinar will be sent to all the registrants. Give us maybe 5 to 7 business days on that, possibly sooner. But I want to thank you again, Geoff, for joining us and for your presentation. And I want to thank everyone who came in and listened and asked questions. And we'll wrap it up there. So
awesome. Thanks very much for the time, guys. Thanks, Tony, for putting this together, and hopefully we'll chat with you soon.
Our pleasure. Take care.